Hello everyone. In this session, I am going to discuss about the very important questions which are expected to be asked in KSET and PU college recruitment exams based on the vectors. What is interesting about vectors is that in KSET physics, about 2 to 3 questions will be asked from this topic, and about 3 to 4 similar type of questions will be asked in PU college recruitment mathematics paper 1. This I am talking about the mathematics aspirants. In KSET physics, 2 to 3 questions will be asked, and in PU college recruitment exam, 3 to 4 similar type of questions will be asked for mathematics paper 1. And maybe 1 or 2 questions from vectors will be asked in PU college recruitment exam for physics paper 2. Okay, I hope you all get what I am telling. Earlier in KSET also there were 2 papers, paper 1 and paper 2. But now they have only 1 paper. They have combined it like in NET exam. But if we see earlier syllabus of PU college recruitment from KEA website, it is very much clear that PU college recruitment exam will have 2 papers, paper 1 and paper 2. For all subjects, for physics, maths, chemistry, biology, all other subjects, there are 2 papers. Now, as far as vectors is concerned, it is a very important topic for both KSET and PU college recruitment exam, for both maths and physics subjects. Okay, I hope you get it. Okay friends, then let's now discuss vectors and most important questions or the expected questions which can be asked in both these exams for both physics and math subjects. Before that, please subscribe to this channel for more useful videos based on KSET and PU college recruitment exams and also other such competitive exams. Even I am making very important videos for teaching competitive exams. That means for the teacher vacancy exams like HSTR, TET, GPSTR, etc. So if you are an aspirant of those exams, then also please do subscribe to this channel, and also please share the videos among your friends and also the other aspirants. Okay, so once again I would like to remind you to please do not forget to subscribe to this channel and to like and share this video. Okay, then without wasting time, let's start. So physical quantities, they can be measured as 2 quantities which are said to be scalar quantities and vector quantities. As you can see here, scalar quantities, they are defined only with the magnitude of the physical quantity. Examples are distance, speed and time. Whereas vector quantities, they need direction along with magnitude in order to describe a physical quantity. For example, displacement, velocity and acceleration. Now there are many types of vectors like zero vector or null vector, parallel and anti-parallel vector, orthogonal or perpendicular vector and so on. Among them, one of the very important type of vector is a unit vector. We need to know about unit vector in order to proceed with what are called vectors. Basically, unit vector, it is a vector with a unit magnitude, or say that a vector which is having a magnitude is equal to 1. You can denote it with the A cap. This will be equal to the vector upon the magnitude of the vector. The vector upon the magnitude of the vector. Here you can see the coordinate axis x, y and z. Here I, j and k cap. These 3 are unit vectors. I cap is a vector along x axis. J cap is a vector along y axis. And k cap is a vector along z axis. When I say that the vector is having just I cap, then I mean to say that the other 3 vectors along y axis and z axis are 0. Okay, means j cap will be equal to 0 and k cap will be equal to 0. That's why I am writing just I in that vector. In the same manner, you can say that if the vector is having j, just j cap, then I cap and k cap are 0 there. In the same manner, you can say for k cap also. That way you can say that the coordinates for I cap will be 1, 0, 0. j cap will be 0, 1, 0 and k cap will be 0, 0, 1. Okay, we write the coordinates as x, y, z axis, right? So that is how we write. For example, if I have a vector A which will be consisting of I, j and k cap, that means along x axis you have I, along y axis you have j, along z axis you have k, you write a vector like this: ax I cap plus ay j cap plus az k cap. Now if I want to take the magnitude of this vector A, what I do? I take the square root of the coefficients of I cap, j cap and k cap. I sum them up by taking the squares. Means here the magnitude of vector A or mod A will be equal to square root of ax square plus ay square plus az square. Okay, and if I divide this vector A by the magnitude of this vector A, then I get this unit vector A cap. Okay, I hope I am clear. We need this formula in many of the problems. So it's better as and when you are watching this video, make a notes and try to recall. You all know this already. You need to recall and make yourself perfect with these concepts now. Now this unit vector is also called as unit normal vector. Okay, because it is perpendicular, right? All the three axes are perpendicular to each other. The x, y and z axis, they are perpendicular to each other. Now we have an example based on the unit vector. The question is that the expression 1 upon square root of 2 I cap plus 1 upon square root of 2 j cap is a. You have to say whether it is a unit vector, null vector or a vector of magnitude square root of 2 or a scalar. Now for this, what you do? You have to take the magnitude. Then only you can understand what type of vector it is, right? If you take the magnitude, you will get to know that it is equal to 1. Therefore, it is a unit vector. How do you find the magnitude? Just now I told you, right? You take the square root of 1 upon square root of 2 whole square plus 1 upon square root of 2 whole square. This will give you square root of 1 upon 2 plus 1 upon 2 or 1. So, if the vector's value is 1, then it is a unit vector. That's why option A, unit vector, is the right answer here. Now, all arithmetic operations are possible among vectors. All arithmetic operations means addition of vectors, subtraction of vector, division of vectors, all this is possible. And multiplication of vectors is also possible. Means you can take the product of vectors. But multiplication of vectors or finding the product of vectors is special because there are two types of them. One is scalar product or dot product, and the other one is the vector product or cross product. Means you can multiply vectors in two ways. One way is the scalar product, the other way is the vector product. Now let us understand what is this scalar product and what is vector product. Now this dot product or scalar product of two vectors A and B, it is denoted by A dot B. And it is defined as product of magnitudes of A and B and the cosine of the angle between them. Means if you want to take the product of A and B, you write it as A dot B, and the value of this A dot B, the vector A dot vector B, will be equal to AB into cos theta. This theta is the angle between these vectors A and B, and the value of this theta will lie between 0 and pi because we are talking about the cos theta. With this, we can also find the value of cos theta, right? So, cos theta will be equal to A dot B upon magnitude of A into magnitude of B. Okay? So, these are the formulas. Better you make the list. This will be helpful for you to solve the problems. Now, if I take the vector A and vector B, this vector A, maybe it will be A1i plus A2j plus A3k, and vector B will be B1i plus B2j plus B3k. And if these two are the vectors, and if I want to take the dot product, I take it as magnitude of A into magnitude of B into cos theta. This I told you, right? But this dot product, it has certain properties. What are they? First is that the I cap dot I cap will be equal to j cap dot j cap will be equal to k cap dot k cap, and this all will be equal to 1 when theta is equal to 0 degree. If theta is equal to 90 degree, then the products of I cap and j cap and k cap and I cap will be equal to 0. Because the dot product, it depends on cos theta, right? Cos 0 will be 1 and cos 90 will be 0. Thus the reason why we have the dot products of two unit vectors is equal to 1 if theta is 0, and it will be equal to 0 if theta is 90 degree. Okay. See, one more thing which you have to understand is, if I am saying that theta is 0 means there is no angle between the two vectors. It means that either they are parallel or anti-parallel vectors. When I am saying that theta is 90 degree, I mean to say that the two vectors are perpendicular to each other. Okay. So these are also helping you in finding out the nature of the two vectors, whether they are parallel or perpendicular to each other or orthogonal to each other. And the third point I already told you, right? If you want to find the magnitude of a vector, you can just take the square root of the sum of the squares of the coefficients of x, y and z axis. Also, if you want to find theta, I told you that cos theta can be found as a dot b upon magnitude of a into magnitude of b, right? Now, if I want just theta, then I put cos in the right hand side. So, cos will become cos inverse. So, if you want to find the angle between two vectors, theta, it will be equal to cos inverse of a dot b, the dot product of vector a and vector b, upon the product of the magnitude of vector a and vector b. Okay. For example, if you have a question like this, the magnitudes of mutually perpendicular forces A, B and C are 2, 10 and 11 respectively, then the magnitude of its resultant is. Now, to find the magnitude of the resultant, you have to take the square root of the sum of the squares of the three vectors, which are the forces here. Just you take it and you find the square root of 2 square plus 10 square plus 11 square will lead you to square root of 4 plus 100 plus 121. It will be equal to 225. Square root of 225 will give you 15. Okay. So the resultant vector is 15. If they have mentioned any units, you can write that units also. I am just explaining here with an example to make you all understand how to find the magnitude of vectors. If you want to write this as a vector before taking its magnitude, how do you write it? You write it as 2i plus 10j plus 11k, because they are mutually perpendicular forces, right? So that vector will be equal to 2i plus 10j plus 11k. Okay. Another example. Two forces I plus j plus k Newton and I plus 2j plus 3k Newton act on a particle and displace it from 234 to 0.543. Displacement is in meters. Work done is, they have given two vectors, they are the forces and they are acting on a particle. Because of that force, the particle is displaced from one point to another. One point is 234, which is its original position, and 543 is the final position where the particle has moved because of these two forces. You have to find the work done. They have given you hint that the displacement is in meters. So what do you do? First see the points of the displacement. Okay, with this you can even do it mentally and find the answer, but I will show you the right method. Work done is force into distance, right? Then force will be equal to the sum of the two forces, the total force, isn't it? Because they are acting on a particle together. So I plus j plus k plus I plus 2j plus 3k. How you add these vectors? You add the I vector with the I vector, j vector with the j vector and k vector with the k vector. This is how you add the vectors. So here I plus I will become 2i, j plus 2j will become 3j and k plus 3k will become 4k. This will be your final force, 2i plus 3j plus 4k Newton. But for displacement, you are not going to add them because you are talking about the initial position and the final position, right? To find the displacement, you have to find the difference between the final position and initial position of the particle. Now you subtract. Subtraction of the vector is also done in the similar way. The I is subtracted from the second I, then the j is subtracted from the next j, k is subtracted from the next k. So 5i minus 2i will become 3i, then 4j plus minus of plus 3j means 4j minus 3j will become j, and 3k minus of plus 4k means 3k minus 4k will become minus k. So 3i cap plus j cap minus k cap meters will be the displacement. Now you substitute this force and displacement in the work formula. Now you have to multiply. How you multiply? Multiplying is also done in the same way. You have to multiply I with the I of the next vector, then j with the j of the next vector, then k with the k of the next vector. Here it will become 2 3s are 6 into I cap into I cap. Now I cap into I cap will become 1, right? Why it will become 1? Because we were talking about the properties, right? What did the property tell? If the theta is 0 degree, I cap into I cap will be 1, j cap into j cap will be 1, k cap into k cap will be 1, isn't it? So that this formula we apply there, this identity we apply there. So it will become 6 into 1 plus 3 into 1 minus 4 into 1. So 6 plus 3 minus 4 will give you 9 minus 4 or 5 joules. So option A will be the right answer. Because this is our one of the starting numerical, I am giving you the clear explanation. After I finish this lecture, you will be able to do this type of a sum mentally. How you do it mentally? First you find the force and you write it down. You do it mentally and write the vector. Then displacement. Just you find the displacement by subtracting the final position and initial position. Write the vectors. Okay. Now you multiply it mentally again. You write it 2 3s are 6 plus 3 1s are 3 minus 4 into 1. That's it. 5 joule will be your answer. You can save your time also. Okay. You can reach to this point only after practice, or else you can't do this. Okay. Okay. Moving on. Now there are few more formulas which will help you all in the exam. If their slopes are given and angle between two curves is theta, then tan theta will be equal to m1 minus m2 upon 1 plus m1 into m2. Okay, this you should know. Where m1 and m2 are the slopes. If they have given you slopes, you can find the theta easily if they are talking about the two curves. I am not doing any numerical based on this. I just want to remind you the formula. That's why I have written it here. Next are the same thing. If the vectors are perpendicular, then the dot product of two vectors will be 0. And if the vectors are parallel, then the dot product of two vectors will be equal to the product of the magnitude of those two vectors. These are the conditions actually. Okay. If they are giving in the question like the two vectors are orthogonal to each other, then you should assume that A dot B is 0 here. Okay. Sometimes direct questions also will come. So that time also you can apply this formula. See, for example, this is a question. Identify the vector that is perpendicular to both I cap plus 2j cap minus 3k cap and minus I cap plus j cap minus 2k cap from the following. This is a very important question because this question was asked in KSET 2020. Now, how do you solve this type of a sum? See, first you have to assume that this vector is vector A and this vector is vector B. Okay. So, two vectors vector A and vector B are given. That vector A is I cap plus 2j cap minus 3k cap and vector B is minus I cap plus j cap minus 2k cap. Now, you have to find A dot C. What is the C vector? The C vector is among these four options, isn't it? The third vector which you are told to find is there in these four options. Actually, you can do it mentally also, but I will show you the procedure. Then I will talk about doing it mentally in your mind. Now assume that the third vector is some vector C, and how can you say that the third vector is perpendicular to these both vectors A and B? That is, how can you say that that vector C is perpendicular to vector A and vector B? You have only one method for that, right? That is, you have to find the dot product of A and C and your answer should be 0. In the same manner, dot product of B and C should be 0. Then only you can say that they are the orthogonal vectors. For that, what you do, you start from option A. Take the vector in option A and do the dot product with vector A in the question. If you are getting the answer 0, then you proceed for vector B dot C again. Then also you should get answer 0. Then you say that the third vector is orthogonal to the given two vectors. Okay, now start from option A. If you take option A, you have to consider here vector C as I cap plus 3j plus 2k cap, isn't it? So vector A is I plus 2j minus 3k. See, don't bother about the caps. I'm not writing it here because in a MCQ based question paper, whether you're writing caps or no is not important. You don't need to waste time like that. Just you have to find the answer and pick the right answer, isn't it? And in vector C will be my option A vector now, I cap plus 3j plus 2k. Now you do the product. How you do the product? You multiply I with I, j with j and k with k along with their coefficients. Now I dot into I will be 1. Then plus into plus will be plus 2 3 the 6. J dot j will be 1. Minus into plus will be minus 3 2 the 6. K dot k will be 1. So this is 1. So this is not orthogonal vector because we need 0 for the orthogonal vector, right? So now don't need to do for B dot C. You just move to option B. In option B again, if I do A dot C, this is for option A. Then for option B, if I do A dot C, it will be I plus 2j minus 3k into 2i plus 3j plus k. This will be equal to again I into I will be 1, 2 ones are 2 plus j into j will be 1 plus 6 minus 3. This will give me 5. So this is also not a orthogonal vector. Now go for option C. In option C, if I do A dot C, this will be equal to I plus 2j minus 3k into minus I plus 5j plus 3k. Now you do the dot product. 1 into minus 1 will be minus 1. I into I will be 1. Again plus into plus will be plus 5 2s are 10. Again minus 9. So this will give me 10 minus 10. This is equal to 0. Nice. This is a orthogonal vector. A dot C here now became orthogonal vector. So I will go for the next step because now I proved that the vector minus I plus 5j plus 3k is perpendicular to I plus 2j minus 3k. Now I should also prove for vector B, right? I have to prove that that vector is perpendicular to vector B also. So B is minus I plus j minus 2k and C is minus I plus 5j plus 3k. This will be equal to minus into minus is plus 1, then plus 5, then minus 6. This will be equal to 6 minus 6. This is 0. Very good. So option C is the right answer because here A dot C is also orthogonal and B dot C is also orthogonal. So option C is the right answer. Now how you do mentally, I will tell you. To do it mentally, what you have to do is just to see by multiplying it directly. Multiply these two vectors, the vector A, this vector and this vector. Multiply it mentally. Then again multiply this vector and this vector. Then again multiply this vector and this vector. Okay. So if you do it mentally, then your time will save. Because I am explaining, I am writing everything and showing you. You don't need to do this in the exam. Okay friends. So this is the right answer. This is how you do for the perpendicular vectors. Only thing is that the dot product of the perpendicular vectors is 0. This you have to remember. Okay. Let's talk about the cross product or the vector product of two vectors. Actually, the vector product of two vectors, it is nothing but the area of the parallelogram between those two vectors. This you remember. And how do you denote this vector product? You denote it by into, means cross. A cross B you say. For dot product you told A dot B, right? For cross product you say A cross B. and the resultant vector will be, you call it as C. This will be equal to A cross B only. But the speciality is that the resultant vector will be perpendicular to the plane containing A and B, such that A, B and C, they form the right-handed system. You can see the diagram here. In this diagram, if this is a plane, in this plane, if you have a hand like this, if you are keeping and then you are curling it, if you are curling it like this, then the resultant vector, it will be C. The C vector will be perpendicular to this plane. This will be equal to A cross B. Okay. See, your thumb is going upwards, right? Your thumb is going upwards. The thumb which is going upward is your vector C. That is nothing but A cross B. But the curling from where you started and where you ended, no, it is moving from A to B. Okay. And this A cross B is equal to AB sine theta into n cap. Because vector talks about the direction, right? The unit vector, you have to denote it here in the A cross B formula. So A into B sine theta n cap. In the same manner like for cos theta, you can find sine theta here. Sine theta will be A cross B, the magnitude of A cross B upon A into B, the magnitude of A into magnitude of B. Okay, clear? Now based on this, I'll give you an example. Now based on this direction, I'll give you one example. The question is, a vector A points vertically upward and B points towards the north. The vector product A cross B is, they have given 4 options: 0, along west, along east, vertically downward. I have made all the 4 directions here. If I have a hand here, see, the vector A is pointing vertically upwards, okay, and B is pointing towards north. Then what is the remaining direction? The remaining direction is west, right? So if it is upward means from north to west only it should move. So this is the direction of the vector. So that's all for this lecture. I am sure that this session would really help both KSET and PU College recruitment aspirants from both physics and mathematics, because vectors come under mathematical methods in physics as well as mathematics. One more thing is that I can guarantee you all that if you learn and practice all type of problems and formulas which I have mentioned and discussed in this lecture, then you will be able to solve all type of questions asked from vectors in these exams. Okay. So then please don't forget to subscribe, like and share this video, and then that's it. All the best. Bye.